As far back as I can remember, I always wanted to be a gangster.
Hello everyone. Welcome to pretty much the first official installment of the Ford Focus ST engine build. And today we're going to get into what I've been doing for the past month and kind of explain why I haven't actually started the build. It's just reasoning because I didn't feel like I was quite prepared enough to actually take on the task, so I went and bought some tools that are going to help me with the full assembly. But today we're going to go into the ring gaps and everything regarding that, and kind of go into all of the measuring and all the weights for the individual pistons that I got and I wrote down, and all the individual pins and everything. We'll get into all of it later, but the main focus of today is going to be the rings and getting those gapped properly, and so you guys know if you are doing this yourself. And you know, I'm shooting for around the 400 horsepower range, so I talked to a fellow friend of mine who built his ST engine with a 2.3 liter stroker kit. So he informed me, he was like, hey, gap the rings to this measurement, and the top compressor ring and the bottom compressor ring, and we'll get into all that later. But right now I'm going to show you what I have written down and kind of go over all the weights that I gathered. So I went ahead and gathered all the numbers weight wise for literally every component that came in the box. So you got your right here, I have it all written down right here. You have your rings, weighed all the rings, the pins, pistons, and then the little circlips, which are the retaining clips that hold the pins in the pistons, and they connect the connecting rod to the piston. Circlips, they were the same across the board gram wise, and then the pistons, that we can get into that later about the different weights for those. The pins, they were a little bit different, and then the rings, they were off by like 1/100 of a gram, so it's nothing too critical. But when I go into the balancing of everything in a later video, which I'm going to be using this little tool here for the rods, and just using the scale for everything else, we'll get into why that's important when it comes to the rotational assembly being balanced, and like the benefits and everything of that. So the main focus of today is the rings. So we're going to get into the proper ring gap that you need to have for our application, which is going to be shooting for around 400 horsepower. I've been talking with a bunch of people about like, hey, what should I set my ring gaps to? Because they do actually come with a sheet that you can reference based on your bore diameter. So depending on the usage here, you got street strip circle, nitrous over 200, blown gas, blown alcohol, that kind of stuff. But what you do is you take your bore and you multiply it by this value right here, and then that'll actually give you the gap that you are supposed to have. Now, just out of curiosity, before we decided to film this, I took some rings, put them in the actual cylinders, and then I actually used the feeler gauge that we purchased as well to see what we were dealing with and see what we were like, how much room we had to play with. And I got a little scared just because on this sheet, doing the math, this is in inches, and the bore of my engine is 87.5, and after doing the math, the values were, you know, they were lower than what I was actually getting. So I was, instead of getting a 0.017 of an inch, like the 17 thousandths of an inch, I was getting like 19 thousandths of an inch. So I was a little scared, but I contacted my buddy Benjamin, who built his 2.3 liter Focus ST stroker, and he said that he gapped his top compression rings to 19 thousandths of an inch, and then the bottom compression ring to 21 thousandths of an inch. So, and he said he had no oil consumption issues, he had no issues ring wise at all. So I'm just gonna roll with that. I've contacted a couple companies asking them, and I have received replies, but they can't seem to find what the measurements that they used. So I'm just gonna go off of what my friend told me, and we shouldn't have any problems. I mean, it's a very important part of the engine. You're supposed to be able to go off the paperwork, but if he's telling me that he's pushing 400 plus horsepower with his ring gap not having any issues, then I think I'll be okay. So I think I misspoke earlier. I mean, I don't know if I misspoke, but I just failed to mention that my bore diameter is 87.5 millimeters, and then this equation right here has to do with inches. So you're gonna have to convert your metric measurement for your bore to inches. So you're gonna have to, you can just look it up, or you can actually measure your bore. I'm just assuming that mine is, you know, correct, just because the engine only had 25,000 miles and I don't have a bore dial gauge to measure it. But when I converted it, it turned out to, what was it, 3.445 inches or something like that. And then we just put it into the equation. But at the same time, we're not going to be going by this sheet. We're actually going to be going by somebody who has seen positive results with the ring gap that they're using with my exact same engine. So yeah, we'll get into right now. We'll open up the rings and show you what we're dealing with here. Ready? Boy, stop. Okay, so when you open the ring set here, it gives you a little instruction of what is what. So when they're packaged, the number 1 is going to be your top compression ring, number 2 is going to be your bottom compression ring, and then the number 3 is going to be your oil ring set. And I've already organized them based on, you know, if you remember earlier, I had all the numbers in the book, so I went ahead and just labeled them like 1 through 4. This ring set right here that I just set down is actually the first ring set, and this is the one that we're going to be using on cylinder 1. So once we're finished gapping these rings, we're going to label them again as number 1, 2, 3, and 4, just so, because that's where they're going to go based on where we're filing. So when it comes to the gapping, the 2 top compression rings are going to be, you know, your key measurement point. You're going to want to get the most accurate measurement, the most accurate ring gap you can with these ones, just because that's going to control how much blow by you have and all that stuff. And then the oil ring set, sorry. It doesn't, I mean, they come with a minimum measurement of 15 thousandths of an inch, so you don't really have to stress too much, because usually they're in spec, but we're going to check them anyways, which we shouldn't have to do any filing with these. But these, this is the top compression ring here, and then this is the second compression ring. So I already know, because, you know, I took everything out of the packaging, and I kind of have an idea of what goes where. But now we're just going to stick these in cylinder 1. Well, we'll start with the top compression ring. We're going to stick that in cylinder 1, see where we're at. And remember, we're going by 19 thousandths of an inch for this one. And then for the bottom one, we're going 21 thousandths of an inch. So yeah, we'll start with the top ring right now, go put it in the cylinder, and then I'll show you a little trick if you don't have the tool to, you know, push this down into the cylinder. You can use the piston head. If you have a flat surface piston, then you can do that. If you have a rounded piston, you can't really do that. So yeah, let's get to that. So right here we have our piston and our top compression ring, and what we're shooting for, again, just so everybody knows, is 19 thousandths of an inch. So what you do is you sit here, you want to insert the ring, just make sure not to, you know, stick it in all uneven and everything. Just go evenly. You take your piston, like I said, make sure it's a flat head piston. That way you can get the ring nice and flush, and then that way they're not, you know, the ends aren't like this or tweaked in any way. Then you want to go in evenly. That way the edge of the piston sits flush with the block. Just take your time, just going slow. Might take a couple tries, just takes a little bit of finesse. There is a tool that's made for this that makes your life way easier, but we do not have that tool, unfortunately. So yeah, right here, this edge right here is flush on all sides. So that's how you know that the ring is sitting nice and flat in the actual cylinder. And like I said before, we're starting with cylinder 1 and it's moving on from there. We're gonna do all of our work in this cylinder right here for these rings, and then kind of move on after we've gotten all of the measurements dialed in for this cylinder, and then just kind of proceed with the rest. So now from here, we grab our feeler gauge. I figured while we're here, we'd show you the actual inside of the cylinders. I already had the block ball honed and hot tanked. So basically what I mean by ball honed is they take this tool, well actually I did it, but you take this tool and you put it on the end of a drill, and you have to make sure it's lubricated, with very lubricated while you're doing this. And you're basically just creating this little crosshatch right here, and that's what the rings are gonna spin on. I mean, it sounds very strange, but while the piston is reciprocating up and down, the rings will actually spin with the crosshatching. So yeah, it's just a cool thing. But we're on to the feeler gauges now. All right, so we're gonna start off with 18 thousandths of an inch right here. I don't know if you can see it. Nah. All right, well, this is 18 thousandths, and we're gonna go ahead and slip this in here. And this is the gap that you're adjusting for right here. And now that we're here, I should explain why we're doing this. So, you know, I could have just said, you know, whatever, and slapped it all together and put the engine together and not do this. But the problem is that if your rings are, you know, they're not gapped loose enough, so that you say your ring gap is actually tighter than it should be. Once the engine gets up to that operating temperature, that gap for the rings begins to close, just because, you know, metal expands. So it begins to close, and then if they ever, you know, meet, there's nowhere for that metal to go, for the ring. There's nowhere for that ring to go but in. So you can have some serious, like, catastrophic engine damage. I've even heard of pistons being chopped in half completely because of too tight of a ring gap. Now, too loose of a ring gap is, I mean, it's detrimental to, you know, your oil consumption, or, you know, blow by and all that stuff. It's just good to have that, you know, that perfect measurement. And from the sources that I've gone to, they said that this is worked perfect for that. No oil consumption, you know, no severe engine damage or anything like that. So that's a really key factor as to why you do this. But 18 thousandths of an inch, here we go. And we're shooting for 19 thousandths, so we're starting off a little bit smaller just to see where we are here. Okay, so we got no resistance there. Maybe like minuscule, but like it's not enough. So I'm gonna step it up. All right, 19 thousandths. Let's see how she feels. Yeah, so what you're looking for is a slight resistance. Ooh, there we go. So we're at 19 thousandths, and I don't know if you can hear it. I don't know if the mic can pick it up, but it's like you'll stick it in and you'll hear like a, and it'll tug on you. Like you want to pull it out, but it'll kind of give you that little bit of resistance. It's kind of hard to explain how to know. I mean, if you have a set of feeler gauges, you should know how to use them and gauge like what is good or not. But right now I'm at 19 thousandths, and it is grabbing the feeler blade here, and that is going to be perfect for our top compression ring. So we only have to touch this one, which is pretty cool. Now we're gonna keep this is gonna be cylinder 1 specific. So our goal was 19 thousandths of an inch, and we met that. So now we're gonna test the second compression ring, see where we're at. Our goal for that one is 21 thousandths of an inch. So we'll see where it lies. Ricers. So now we have our second compression ring, and for the Molly pistons, the rings for these pistons, I don't know if you can see it, there's a little thing that says top right here. Yep. See that right there? Top. Do not confuse that as the ring being the top compression ring. Do not confuse this. Top is just indicating that this is the top side of the ring. So you don't want to put it upside down. This is the top of this ring, but it is the second compression ring. So if you're ever getting moly pistons, just remember that. And you're going to build yourself, remember that. So the same process as the top compression ring, just slide it in. And it's going to be exactly the same procedure for every single ring that we're measuring here. Just put it in, take your piston. Like I said, exactly the same process. Alright, so we got the ring in there nice and flush. I'm just going to start with 18 thousandths again, just so we're going the same here, because I don't know what this is going to measure. Oh, that's a little tight. Okay, so at 18 thousandths we are grabbing. So that means we're gonna have to do some cutting, which is exactly why I got the ring cutter. The ring file. So you guys are about to venture on this journey with me, filing my first set of piston rings. Which this whole process is a learning experience. And I'm very excited. I'm really excited to use that now. Alright, so there's a lot of risk going into this. Could remove too much, which means you would have to order, new rings, all that stuff. But the key thing to using this tool, let's walk over here. So you want to make sure that when you are cutting the ring, that you aren't, cockeyed like this, or at any weird angle to where the two ends aren't exactly parallel and flush. So you want to do your best with this tool. Now this is a very cost efficient tool. This is a manual ring filer. You just use this handle right here and you grind away on the ring. There's electric ones you can buy out there that are a lot nicer, that are like close to $300. I figured if we're just starting off right now and we're just doing this for my engine right now, we won't really need to invest in that. Plus I've heard this works really, really well, and all the reviews said it did its job. So whenever you're doing this, the machine will always spin backwards, but this you can go forward or backwards. What you don't want to do is grind this way and grind outwards of the ring. You never ever want to grind outwards. You always want to go towards the inside, that way you don't damage the treatment on the outside of the ring. And also you want to grind inwards because you don't want a little edge on the edge of the ring here too. So once we're finished grinding it, we can use the file here. When you're finished removing material and you want to go measure it again, you take the file and gently remove any sharp chamfered edges. Don't round it off, but just get rid of any foreign material that's still on there. So yeah, this is a first for me, guys, so get ready to join me. So right now we are sitting at 18 thousandths of an inch, and for this one we want to be at 21 thousandths. So let me just get this set up here, make sure it's flush. Alright, now we take our file, just remove any of that sharp edge there. Just a light file, nothing crazy. Alright, so I'm going to set the ring back inside. rubs keep getting caught. There we go. Just get the piston. Just do the same thing. We're just repeating the same process here. Okay, I'm gonna go back to 18 thousandths. See if we have gone up. It's not catching quite as much as it was, so I'm gonna step it up to 19 just to see where we are. Yes, this is a very time-consuming process, but it's well worth it in the end. Okay, slightly catching here. Just make sure the ring is still flat. Alright. I'm just gonna make sure that the ring is still flat, you know, take it out again and then press it back in, and then we'll test the 19 thousandths again. Alright, so I just readjusted it, pulled it out a little bit, and then pressed it back in with the piston. I just wanted to make sure that, you know, we were flush in regards to the two ends. So I'm going to measure 19 thousandths again. And we still got some more grinding to do. Alright. Let's get back to the wheel and let's grind it some more. Alright, so done a little bit more grinding. It's like I said, it's a very time-consuming process, and if you don't have patience.
Started the grinding on this at it was like, anyways, it was like 9:40 or so. We're at 10:20.
Yeah, so I mean, this is just one cylinder. Keep in mind as well, and I only grinded the second compression ring, so. Personally, I just kind of, you know, it gives me a little bit more confidence in the engine that it's going to be built correctly. I mean, I could have just had somebody else build it, or, you know, just outsourced an engine from somewhere else, but I really wanted to learn doing this because eventually I want to do this as like my career. So, I mean, I feel like this is a really good stepping stone, and it's a cool experience just to, you know, experiment with all this stuff and get to know engines and all that. But if you focus here, you can see that the gap, I don't know if you can see the gap here.
Yep.
So the gap, if you look at the actual ends of the rings, they're perfectly parallel. They're identical. So that's going to be very important that when you're using the grinding wheel, you don't put it cockeyed or anything like that, because it'll cause issues when the engine's actually running. So here, right here is the 21 thousandths, and let's see here. Yeah, there we go. And it's got the perfect amount of resistance here. So we'll roll with that. And now I'm just out of curiosity, I just want to see what the oil ring setup is. Just because like there is a minimum of 15 thousandths, but I doubt it's gonna be like anywhere near that. But we're just gonna test it just to see where we're at when it comes to that set of rings.
Considering it's a low tolerance ring.
Yeah, exactly. All right, I'm just gonna set one of these rings in here, and then just same exact process as we've been doing this whole time. Precise. And yeah, right here. I'm at the minimum right now of 15 thousandths, and it's It's not even catching.
Out of curiosity,
Ow.
do you want to find out what it's at?
I feel like it's not really necessary, but you know, out of curiosity, I'll start at, you know, let's say 18,000. Nope. So step it up. And like Ben said, these aren't a super high tolerance ring, because their main job is just to supply oil to the actual cylinder wall. So
In a sense, the looser the better.
in a sense, but
In a sense, to an extent.
nope. 20 thousandths. Film a little bit, but I mean, there's really no need. The minimum that they say is going to be that 15 thousandths. I'm just going to put this one in as well. Now, if people don't know, there are parts to this oil ring assembly. I'm going to go get the other one real quick. The way this is going to sit on the piston, it's going to be this little bottom ring here, and then this wavy looking one is next, and then another top ring to kind of trap it in there. And basically what you want is for the oil to get trapped in these little grooves here, and then if once the oil is in these grooves, it'll help lubricate the cylinder while it's reciprocating up and down. That's the main purpose of these here. But the clocking is very important with the rings as well, but we'll go more into that when we're actually, you know, putting the pistons in the block and everything like that. So right now we just wanted to show you guys that, you know, we're doing all the gapping of the rings ourselves, and we're having fun doing it. I'm having really a lot of fun right now. So now we're just gonna have to go through all the rest of the cylinders, because these tolerances aren't so, you know, they're not as important as the top two compression rings. I don't think I'm going to check the rest of them. I might. Yeah, I am. But it's not going to be as serious as the top two compression rings. Alright, so it's a new day. We kind of ran out of time that night that we were doing cylinder 1. So we only got to cylinder 1 and haven't even touched the rest of the 4. But I wanted to mention that if you remember the method we were using to set the rings square in the bore, that method it worked, but I did some rethinking, and I recalled that there's a better way if you don't have the actual, you know, ring squaring tool. If you have like a extra piston, or if you want to use one of the newer pistons, you can actually install one of the compression rings, the second one in particular, to actually act as a way to be actually like flush with the deck. So when I'll show you right now. So you put in the ring here and make sure it's the correct direction. So you set it in the bore, and then you take your piston and make sure it's clean, and it has to be a flat top, like I said. And then you make sure that the ring on the piston is pretty much centered on the piston. That way it'll have an edge to it. You push it down, and then right there, that's going to stop the piston from going any farther, and actually make sure and guarantee that it's actually going to be flat and square in the cylinder. So just so you guys can see, that's the top compression ring, and we were going for 19 thousandths. Just to show you guys that we are getting the same measurements. That method that I was using before wasn't technically inaccurate, but there's just a better way of doing it, an easier way of doing it.
And there's more room for error with that other way.
Yeah, right there. So we still have the same resistance here. So that's 19 thousandths, and that's exactly what we're going for. So I did exactly the same thing off camera with the second compression ring, and 21 thousandths came up. So everything's good to go with that, and we're just going to proceed with the rest of the cylinders. So I went ahead and did the rest of the cylinders for the rings, and after I grinded all the rings down to the proper specs, I just labeled each one, you know, 1 through 3. So there's 1 through 4, or yeah, 1 through 4. My bad, I don't have a three banger. But there's number 2, there's number 3, and then here's ring set number 4. So those are gonna stick to their assigned cylinders, just because they are adjusted for the bore for each individual cylinder. So we'll have to match these up with some pistons, and they'll have to stay with those pistons. And I have the pistons numbered as well, so we'll probably just put these with the corresponding numbered pistons, and then just go by weight from there, which we'll get into with the next video. And in that video, we're going to be going through all the measurements we took for the pistons, and all the other components of the pistons, and we're going to be weighing the big end and the small end of the rods, which we can show you how that's going to work right now. So we're going to be getting into balancing the rods as well, and that's going to require this little setup we have here. It was about 200 bucks. I mean, you got to buy the professional tools to get the results you really want. So we went ahead and did that, and then as well with the ring filer. But pretty much what you do is you set either the big or small end of the rod here on the tool, and then you set this mechanism onto the scale, obviously with the cover off and everything. But that'll give you your measurement for the big and small end weights of the rods. So in the next video, we'll get into all of that, and how to remove material, where to remove material on the rods and the pistons themselves. So yeah, we hope this video, you know, we hope you enjoyed this video, and we hope you tune in for the next one when we're getting into, you know, the weighing and everything. But for now, the piston rings are already filed, they're gapped and good to go. So after we get everything balanced and all the same weight all around, and get the rotational assembly balanced, then we'll actually be able to start assembly. So I still need to get the ring compressor so we can stick all the entire piston and rod assembly into the cylinder. But from there, it's, you know, we got to measure the bearing clearances, but I'm going to do all that at once, rod bearings and main bearings. So yeah, we'll get into that later in the future, but we hope you enjoyed this video. It's not really a quick video, but you know, it's just a good instructional video to give you an idea of what goes into gapping the rings and such. So yeah, we hope you enjoy. Follow us on Instagram if you want to keep up with everything else that we got going on, and make sure to subscribe if you want. Comment below if you have any questions or comments about what we did, and yeah, we'll see you in the next video.